Hi everyone, time to work on our little practice test here. And I think I got my cord, never mind. Okay, first one, let's solve this first one by graphing. I'm going to rewrite that first equation as negative 3x plus y equals negative 3. And then I'm going to set up and make the intercept table. When x is 0, y is negative 3. When y is 0, negative 3 divided by negative 3 is 1. So let's do 0, negative 3. Let's do 1, 0. And let's very carefully graph. I'm just kind of trying to follow that same slope. Okay, so there's that first one. I used the intercepts. I did switch these two terms around just so the x term's first. This one I'm going to use the y equals mx plus b. The slope is 1/3. The y-intercept is 5. So I'm going to go up 1, 2, 3, 4, 5. I'm going to start there. Let's change colors so that we're seeing a difference here. And then I'm going to go up 1 and over 1, 2, 3. Oh, look at that. I'm right on it. I'll just do one for good measure here. Do one over here for good measure. And I'll draw this. The solution would be the coordinates of that point right there. And that looks like 1, 2, 3, 1, 2, 3, 4, 5, 6. 3, 6. X is 3 and y is 6. I told you to write the ordered pair, just kind of write it that way. That tells, this is the point, x is 3, y is 6, that works in both equations. It's the ordered pair that works in both. And if I look, y is 6 minus 3 times 3. 6 minus 9 is negative 3. And this is 6. 1/3 times 3 is 1. 1 plus 5 is 6. So that does work in both. All right, number 2. Solve x plus y equals 6 and 3x minus 2y equals negative 2 using substitution. We want to find the ordered pair that works in both of those. I'm going to start with the x plus y equals 6, and we're going to use substitution. So I want to get one of the variables by itself. I'm going to do the x. You could do the y just as easily as you could do the x. I'm going to take the x now. So that's first step is to isolate one of the variables if necessary, and it is necessary. And then it's take this expression and put it in the other equation. So I'm going to put the 6 minus y right here where the x was. 3 times 6 minus y minus 2y equals negative 2. Doing this lets us get it down to just y's, not x's and y's in the same equation, which means we can solve it. 3 times 6 is 18, minus 3 times y minus 2y equals negative 2. So that is 18 minus 5y equals negative 2. I'm just solving, so I'm going to subtract 18 from both sides. That cancels, so that's negative 5y equals negative 20. Divide through by negative 5, you got y equals 4. So I have y equals 4 here. I am going to, so x plus 4 equals 6. I put the 4 in place of y in the first equation. If I subtract 2 or 4 from both sides, I get x is 2. So my ordered pair here for x, y is 2, 4. All right, third one. We're going to solve either using substitution or graphing. Substitution might be a little, I think graphing may be a little easier on this one than substitution. And I'm actually going to do it that way. I'm going to take 2x minus 3y equals 12 and set up the intercept table. Let's put x as 0, and let's put y as 0. When x is 0, we got to take 12 divided by negative 3, which is negative 4. When y is 0, we have 2x equals 12, so we have to take 12 divided by 2, which is 6. So let's plot the first equation. We're starting at 0, negative 4, and then we have 6, 0, 2, 3, 4, 5, 6, 0. Okay, just kind of taking a look. And I want to be real careful, because when you solve by graphing, you have to have a good graph. So that's what we're doing. That's the graph I have for the first one. And I'm going to use a table also, an intercept table for this one. Negative 4x plus 6y equals 36. When x is 0, you got 36 over 6 is 6. When y is 0, you have negative 4x. Sorry, lost my train of thought there. Negative 4x equals 36. Divide by negative 4. And you got negative 9, I believe. Okay. I'm going to redo this. This line is not, I mixed my, no I didn't. It's good. Never mind. Okay. Scratch that. So I've got negative 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's that point. Now 0, 6. 1, 2, 3, 4, 5, 6. Okay, so I'm looking for the point of intersection. These darn things look parallel. So there's no solution, because we got parallel lines. All right. Now number 4. It says give the parent function name for this. Describe the transformation represented by the equation. Then graph the parent function and the given function on the same grid. Okay, parent function name. This has got an x and a square. I think we got to call it a quadratic. The description of the transformation. I think we need to translate, I would use the word slide also, 1 unit, now it's negative 1, and counterintuitively I think we have to go right there, and 3 units up. 1 unit right and 3 units up. All right, well, let's get the parent function drawn. We've done it so many times. 1, 1, and 2 to the second power is 4. 3 to the second power, 4, 5, 6, 7, 8, 9. 3 to the second power is 9 over here. Let's go 9 here. 2 down there, 1 there. Okay, so here's parent function. And I'm going to write this as y equals x squared. Now we are going to translate it 1 unit to the right. I'm going to do that in blue. 1 unit to the right and 3 units up. So the vertex is going 1 unit right and 1, 2, 3 units this way. This point, 1 right, 1, 2, 3 this way. This point, 1 right, 1, 2, 3 up. Let's see, let's do this one. Go 1 right, 1, 2, 3 up. And let's do this one. 1 right, and 1, 2, 3 up. And I think I'd run out of graph if I tried to translate that other point. There is my graph. Number 5, a function's parent function is the absolute value function, and it is being shifted 3 units down. So I'll put the -3 out here. Oh, crud. Okay, let's change that to 3 units right. I'm changing this. Let's change the thing. Keeps rolling, so we're going to just deal with it. 3 units right. So let's go x -3 and put that in absolute values. That'll move it 3 units right. And then 4 units up, let's go +4 and write that one. Okay. Number 6, we're going to give the equation of this. It is an absolute value. And it requires a flip, a negative. And you know, usually the absolute value, you go to 1, 1. This is going to 1, it's going 1 over and 1 down because it's negative. Now we're going 1 over and 2 down. So we're multiplying this by a -2 times the absolute value of x. And we've got a 1, 2, 3 unit shift. And up 2 units. Okay. Guys, that is that. You guys take care now.